Good morning, guys. Our goal for today is for you to be able to interpret the meaning of multiplication and division using models, calculations, and word problems. This comes from the standard that says we have to apply and extend previous understandings of multiplication and division to divide fractions by fractions. So we're going to use what we know already, and we're going to extend it a little bit. Caleb says, how many halves go into 6? Good. Aiden, what'd you say?
I put 6, like, it's exactly the same as Timothy.
Okay.
Because the half, it does represent a number, half of 6, which is 3. So I agree with Timothy because half of 6 is 3, and we're trying to find out how many times it can go into 6.
Okay, so did you hear what Aiden said? Aiden, are you making the statement that the answer is 3?
No.
No? Okay, so you said something about 3.
Yeah, because I'm making a statement of how many times 3 can go into 6.
Is that what it says?
No, because it's saying 1/2.
Okay, so I would stick with that idea, because that's what you have on your board, isn't it?
Yeah.
How many times, you said how many times this goes into this?
Yeah, because the half is representing a number.
Okay, I agree with that. Really good, Aiden. Really good thinking. Priscilla, what'd you write? This is the last one, then we'll move on.
I wrote 2,
Okay. By the way, did anybody get an answer? Did anybody get an answer? Landry, what was the answer?
It was 12.
12? Okay. So think about it. We've talked about these. Jed says it's just like 6 times 2. Timothy and Caleb and Aiden says how many halves go into 6. And look at the picture that Priscilla drew. Do you think that's a good representation of it? How many halves did she find? How many halves are there? Specific ones. 12. So is that a good picture?
Mm-hmm.
Does it go along with the descriptions that we have up here?
Mm-hmm.
Okay, good. Riley? Okay. Good job, guys. Here's what I want you to do. Clear your board. I appreciate your participation and your input. You've got the correct thinking here. What we're going to do next, we're going to transition just a little bit. You look up at the board. My helpers are going to help me, but we're going to each group is going to get a bag, and it's going to have blue cards and yellow cards. One of the types of cards is calculations, and one of the other type is words and a diagram. And so what you're going to do, here's a list, okay? First thing is you're going to take turns, you and your partner, to match a calculation, so a blue card with a yellow card, okay? And it's going to describe the interpretation of the calculation. Second thing, when a match is made, I want you and your partner, I want you to use those guiding questions on your desk. I want you and your partner to explain to each other or ask each other questions about why they match, and how you could maybe find the answer. So I want y'all matching, and then you can use your boards if you want to jot down some ideas or even find the answers there. And I want you working together, I want you using your talk moves and using your guiding questions that you have on your desk. Third thing, if there's not a diagram for your calculation, there is an empty little card. You can make your own. If you don't quite get there, that's okay. Lastly, you might find more than one calculation that matches a word or diagram. That's okay. Okay? And this is the whole point of the lesson. So you might find more than one calculation that matches a diagram, or you might find more than one diagram that matches one calculation. And that's okay. I want you and your partner to match them as you see fit.
Three groups of 1/6. Okay, so all that 6 is just 1/6. And we need to find 3 groups, which we already did because it's 2. But we need to find a problem. 3 groups, 1/6.
Okay, that's 6 divided by 3. What does that mean? How many times is 3 going to 6? What's the answer to that?
2.
2. Look at your picture. This says 6 groups of 3. How many altogether? Does that equal 2?
1/3 of 6.
So it's gonna be this one. No.
Keep thinking.
And then they be like, well, that's what I thought, but then I was thinking like the diagram would go together, and then you would like read this and like whatever that is, and find the answer. And she thought it was like
Either method, it's your choice. Either method, okay? Have you been finding the answers as you go? Okay, so that may be a way to kind of check to make sure you're thinking is right. Are you, that, what you wrote, 6 divided by 1/3, is that the same thing as this card? Do you know what the answer to that one is? Look at how you matched it. Is that the same thing? Look and see if maybe this, because you actually wrote the calculation down for the card. See if you can find it over there. I spy it.
that one. Because you wouldn't divide them into 2 because
About
you
6
divide
minutes.
6 wholes into thirds. So it's 8 minutes. So I was thinking dividing the whole 6 and then it would be, but it was actually dividing each of 6.
So I think we're supposed to just draw it. Oh look.
Yeah, we have to draw it too.
The answer is 2. Is this what the model shows? It says 1 fraction of 1/3 is 1/6. Well, look at this one. It says 1 fraction of 1/3. You see how it's kind of dark around the third? Give me 5. Thank you. Okay, y'all been doing a really good job hearing some really good conversations, and I know that some groups have made more matches than others, and that's okay. I wasn't expecting you to match all of them. If you did, that's great. If you didn't, don't worry about it, because what we're going to do now, I want to revisit just really quickly. I want to revisit what we talked about on this page here. I want to look at our ideas. So you've seen some more calculations now, and hopefully you've got a better idea of when to choose multiplication and when to choose division. So I just want to really quickly look before we move on, and I want to look and see and maybe make sure that all of our ideas are correct, and if not, maybe we can add something. Okay? So from what you've seen right now with the cards, we've got 3 times 6, and we said that it either equaled 6 plus 6 plus 6, or 3 plus 3 6 times. Is that okay how it is? If it is, give me a thumbs up. If it's not, give me a thumbs down. Use your own brain to vote. My question was, look at the next one. 1/3 times 6. All we really have is a number sentence. We didn't have any words or anything. Could we maybe add something to that? Because we said that we could add 1/3 6 times. 6 times. Joshua, what do you think?
You're changing the size. You're multiplying 1/3 by 6 by changing it to a higher size, but still leaving it on thirds.
Okay. I think I heard you and Jed talking about this, and when you were looking at the calculations, you and him were reading it in a different way. Instead of reading it as 1/3 times 6, you were saying something else. What were you saying? Do you remember? When you saw that multiplication sign, what were you saying in place of it?
I don't know.
You don't know? Anybody? It was kind of on some of the descriptions. Yes, Riley? Is there a different way that we could maybe write a description for this one? What could we write? Camille, what could we write? Yeah, using that word that Riley just said.
How many times 1/3?
Can you use the word of in your sentence? What are we trying to find when we do 1/3 times 6?
How many times 1/3?
What number times 1/3 will equal 6?
Does that work? What number times 1/3 gives you 6? Does that work? Is that what this means? Anybody agree or disagree? Jay, what do you think? Can you add something to that, or maybe
6 groups of 1/3.
6 groups of 1/3? Is that kind of what goes along with this? 6 groups of 1/3. Okay. Yes, you're right. So kind of similar. But I want you to keep thinking. Keep thinking. Riley told us that there was that word "of" that we could maybe use. Jed, do you remember what you were saying?
What is 1/3 of 6?
Okay. Did you hear him? What did he say? What did he say, John? 1/3 of 6. Think about it in your head. If I have 6 pizzas and I want to find 1/3 of those pizzas, how many pizzas are there going to be? How many? 2. Which is what the answer was when we added all these together, wasn't it? We said it was 6/3. Okay, so Camille, do you see how we can write this as a description now? What can we say?
1/3 of 6 equals 2.
Yeah, 1/3 of 6 equals 2. You okay with that so far?
Yes.
How did you get from that statement? How did you get from the one that we had, the calculation? We had 3 divided by 6. How did you get to 1/6 of 3? Okay. Is it okay if we do that? If we use that rule? Remember we said when dividing fractions, what? That's why. Slip the second fraction in, multiply. Is it okay if we do that with the whole numbers? Can we do that? Can we make these whole numbers fractions? Yeah, we can put a 1 underneath it. And John says find the reciprocal of the second one and multiply. 3 times 1/6. So is it okay that he says 1/6 of 3? Is 1/6 of 3 1/2? Yeah. Well, there are multiple ways of thinking about these calculations, guys. This is what I want you to see. What we're going to do now is we're going to add another step. I don't want you to mix up your matches. Okay, hold on for a second. I don't want you to mix up your matches because what you're going to get now is you're going to get some orange cards. You're going to get some orange cards. And the orange cards are going to have a little pizza story. So there's going to be a little story about a pizza delivery, and what your job is, let me give you your directions. What your job is you are going to match the story to a calculation. What I want to see is that you're going to match a pizza problem and a calculation together. You're going to match them. You're going to glue them on that paper. So be careful. Be real sure before you glue it. The calculations should show one correct way of solving the problem. So if there are more than one, you can just choose one. So you're just looking for one. Next to each pairing, this is important. You and your partner are going to use your guiding questions and your talk moves, and y'all are going to explain why the cards match. You can either use words or diagrams. Lastly, you should write an answer to the problem.
Okay, that's great. So maybe 1/3. So it's 1/3. Dividing out 3 yes, divide by 6, I think. Let's just say 3 boxes of pizza are delivered to a party.
Would you like to?
Each box contains pizzas.
What are you trying to do on this?
Okay, so much of the 6 pizza that she ate one.
Okay, and you. Oh, okay. So you've already found the answer. Okay, that's a good way to solve that problem. So you're trying to find the calculation now. Okay, keep going.
Okay, so pizza 2, pizza 3, pizza 4, pizza 5,
You choose. That's your choice.
So 1/3 divided by 4. Okay, so we got 3 boxes.
And then make sure you follow the answer.
So we need something that has 3 boxes. 3 boxes that have 6 in each.
Make sure you follow the directions of the board.
3 together. I'm kind of thinking pizza.
Okay, thank you. If you notice, I was walking around and I was passing out pink sticky notes. If you received a pink sticky note, you and your partner are going to present one of your questions or one of your matches. Now, that doesn't mean that everybody else gets to take a break and kick up their feet, okay? What you're going to be doing as the audience is we're going to be critiquing them, okay? That's one of our mathematical practices. It says that we have to be able to critique the reasoning of others, and we're going to do that by listening. We're going to do that by comparing arguments. So one might say, I agree with that, or I disagree with that. We're going to maybe find flawed logic if there is some, and we're going to maybe ask questions or ask them to clarify their thinking. So what do you think that I should be looking for, or maybe you as the audience should be looking for when someone comes up here and presents? I need your ideas. So we're going to kind of make a little rubric for ourselves. What do you think you or I should be looking for when people come up here to present? Jay?
If the answers are correct or incorrect.
Y'all think that's appropriate? So we want to say correct answers. Okay? We want to leave it? Want to leave that? Okay. Riley?
Another thing you could look for is if the model is reasonable for, or if the model or sentence is reasonable for the problem.
Okay, model or sentence
That they chose.
is reasonable. Do you think that's a good thing to look for? So we want to leave it there? Okay, good guys. Priscilla?
Politeness.
Maybe being polite. Who being polite? The audience. And then what if we critique their reasoning and then they get their feelings hurt and they huff off and they're mad? We want them to be polite too, right? So we want to have reasonable arguments where we're being polite. We're just trying to help others. So I like that. We're looking for politeness for both the presenter and the audience. Caleb?
That you speak clearly and loudly.
What do you think about that? Is that super important? Speak clearly and loudly. / loudly. Definitely important. Lillian? What? So you as an audience are looking for clear thinking? What do you think? Is that good? Can you maybe expand on what you mean by that? What do you think? What do you mean?
Seeing them work out the problem and kind of understanding what they do.
Okay, so you as the audience are looking for clear thinking. And if it's not very clear, maybe we can, as an audience, help them make it more clear for us. Okay? Anything else? We're going to take about 15 minutes to do this. I want you to be listening. If you're not presenting, your hands are still, your markers are capped, and you're really, really looking up at the board to make sure that all of these things they have on their poster. Want to make sure the answers are correct, make sure that their thinking is clear. So how about Jay and Caleb? And if you're presenting, if I gave you a card, and if we have more time, we may get some more people to come up. But pick one to show us. Okay, boy?
Okay. So we put 3 boxes, and so we put 6 pizzas in each box. So
To signify the pizzas in the box.
yeah, and so we knew that 3 times 6 is 18. So there are 18 pizzas in total. Yeah.
Okay, so let's check for a few things. Riley said we need to make sure that the models are reasonable. Riley, what do you think? Are the models reasonable for their story?
I think so.
Think that's okay?
They did show they did explain how it was the different boxes with the pizzas in there. So.
Okay. Do you think that their answer is correct? Should it be 18 pizzas altogether? Did anybody do this problem? Anybody choose this one? Did you get the same answer? Okay, good. Is their thinking clear? Were they pretty clear in the way they explained it? Okay. Do you have any questions for them?
Any questions?
Jay and Caleb, as y'all were working together, were you asking each other any questions?
Yeah, well, I kind of didn't understand it, then he, clarified it.
What did you ask him when you didn't understand it? Oh, and what'd you say?
I just said that, well, since there are 3 boxes and it says that each box contains 6 pizzas, that there should be like 3 little squares with 6 pizzas in each whole box.
Okay, did that make a little more sense to you? Okay. Anybody have anything to add to their presentation? Let's give them a round of applause. Good. Okay, Ron?
6 pizzas are placed in 3 boxes. The same number goes into each box. How many is this?
So we thought it would be 1/3 times 6 because if you they're asking each box, so each box would be 1/3 like that, which is not very bright, but it'd be 1 box like that, and so we just drew out our 6 pizzas. So we drew 6 circles and just put 1 P represent pizzas, and then we just boxed them.
Because it said there you have your 6 pizzas and they have to equally be divided into 3 boxes.
And what was the final question?
The final question was the same number goes into each box. How many is this? So we found out that 1/3 times 6 equals 6/3, which equals 2.
So 2
There's 2 in
pizzas
each box.
into each box.
What do y'all think about there? Did anybody choose this question? Or this pizza problem? Did y'all choose this one? Did y'all get the same, did y'all choose the same calculation?
You did it differently.
Okay, what'd you choose?
6 divided by 3.
6 divided by 3. Did it give you the same answer? So they're saying that for this pizza problem, you could either do 1/3 times 6, or, what'd you say, Priscilla? 6 divided by 3. Do both of those work? Do they both give you 2? Okay.
So the problem says a whole pizza is divided into 6 equal slices. I eat 3 of these. What fraction of the whole pizza do I eat? So we divided it into 6 pieces, and and since it said he ate 3 of these, we shaded in 3 of them, and 3/6 is equal to 1/2. So we know he ate 1/2 of the whole pizza. And for a problem we put 1/6 divided by 1/3.
Can you scoot over to the left a little bit? Okay. So, will you read the question one more time?
A whole pizza is divided into 6 equal slices. I eat 3 of these. What fraction of the whole pizza do I eat?
Okay, so tell me why you decided to choose 1/6 divided by 1/3.
Since we're dividing it into 6, since we're dividing it into 6, and then we're dividing that into 3, or by 3.
So, 6 people are each given 1/3 of a pizza to eat. How many whole pizzas are they given altogether? So, we chose 6 times 1/3 because there are 6 people and each person is eating 1/3. So, we drew 6. Each circle represents 1 person and how much of the pizza they got, and each one represents 1/3. And this equals 3 people. The amount for 3 people equals 1 whole, and the amount for the other 3 people also equals 1 whole, so they are given 2 whole pizzas altogether.
Was there another calculation that gave you the answer too?
I think it was 1/3.
6 divided by 3. Could we do that one too? 6 divided by 3. Would that work?
But we use 6 divided by 3 for that.
Oh, for the other one. That's okay. So it's okay if I use either of those calculations. Isn't that strange how we've been seeing that you can use either of them? It just what does it depend on? What are we looking for? Riley?
If you're dividing or multiplying.
How did you decide when you needed to divide or when you needed to multiply? Emma?
Well, sometimes we even just look for keywords.
You look for keywords. What was a keyword that helped you decide?
For multiplying, it would be of, and for dividing, it would be like maybe is.
Okay. Was there another keyword you saw, Caleb?
Oh, for dividing, it says divided.
Oh, some of them even said divided. Okay, was that a key for y'all, for those of you that chose some of the questions that said divided? Did y'all end up using a calculation that said divide? Yeah? Okay, Camille.
For the multiplication, we looked at all together, and for division, I kind of saw me.
Oh, okay. So did anybody else notice that? She said for multiplication they looked for all together, and for division they said maybe some of them said how many or something like that. Okay, interesting. Here's a few more questions I want to ask you, and then we'll kind of wrap this up a little bit. Y'all been doing a really good job. I just have some final questions. Why do you think that some of the calculations matched up to more than one word problem? Why was that? Why did some of the calculations match up to more than one word problem?
Because maybe they were different problems, but they could equally decide that they were the same problem put in different form.
Same problem put in different form. It's interesting. Landry.
I agree with Parker, because, like, if you have one number, like 6 divided by 2, you'll get 3. And if you do 1/6 multiplied by 3, I said 2 and 3, it would equal the same number as you got.
Okay, so you kind of agree with what she said. It's just the same. It's the same answer you get, but it's a different way of solving it. Maybe. Ben.
Sometimes you can use different methods to solve the same problem. And if you have, going back to, if you have like 6 divided by 3, you can use multiplication to solve the same problem.
Okay, interesting. Anybody agree with that? Anybody? Jed agrees. Caleb agrees. Good. Priscilla, you have something to add?
I think it is because there are more than one way to look at the problem, and so there are more than one way to solve the problem.
What do y'all think about her statement?
And they could be all different. But
They could be different.
The answer should be all the same.
Zach, you agree with that? Okay. Camille, one more thing?
I think they're all in each other's family, like 6 divided by 2 are like 3 times.
Okay, so it's kind of, what do you think about that? Maybe kind of like a fact family, how we know that 6 divided by 3 is 2, and 2 times 3 is 6. There's multiple ways of doing that. Interesting, Camille, really good thought. So, and we kind of answered this second one. My question was, how can we distinguish when we are multiplying or dividing? And Emma, you said look for what?
And I said occasionally the word is.
So some key words, so we can distinguish it by looking for key words. Timothy, what did you do to figure out when you're multiplying or dividing?
Well, it shows that,
You want me to come back to you? Okay, I'll come back to you. Zach, what do you think? How did you decide when you're going to multiply or divide?
I decided when, like on the first problem, when it said 3 boxes of pizza are delivered to a party and each box contains 6 pizzas, I knew to multiply because I knew that each box had 6 pizzas, so I'd have to multiply 6 by 3 to get the answer.
So do you think you used some key words and you kind of mentally thought about what the picture would look like? And I did see Zach, he was drawing pictures and stuff, and so that helped you? Good. Anybody have anything else? Priscilla, one last thing.
Of in each.
Okay, like Emma said.
Something and how many are in each.
Okay, of something and how many are in each. Timothy, did you think of another idea?
I think so. Because how it says, it's divided into 3 equal slices, like, there are those 3 main parts, and then it says, I come into 6 of one piece, so, it's like, you draw, like, some more lines, so you divide it into 18s.
Okay, so give me 5. Okay, just want to wrap up really quick. Today, I hope that you can now interpret the meaning of multiplication and division using models, calculations, and word problems.